First, make a substitution and then use integration by parts to evaluate the integral. The integral we have here is the sine of the natural log of x dx. So we're going to first start out with our substitution. So our variable in our integral is x, so we're going to use y to use that substitution. So we're going to let y equal the natural log of x. Okay, and so therefore the derivative is going to be 1 over x dx. So let's multiply both sides by x, and so we get x dy equals dx. But now in this scenario, we can't substitute dx to be x dy, because then we're going to still have two different variables, and we want to write this substitution in terms of y. So we need to figure out, okay, what can we do here with this x dy? So now we got to figure out what x is, and so we can substitute x back up in this particular problem, because we know that the base is e, right? And we want to write this as an exponential as opposed to a logarithm. So y is the exponent on base e to get x. So that means that e to the y is equal to x, which means now that we can substitute this x to be e to the y dy, which is equal to dx. So now we can use that as our substitution, and we can also use this as our substitution. So let's go ahead and do that. So for step number 2, we're going to write out our integral, the sine of the natural log of x dx, with our substitution. So we know that we have the sine, and we know that the natural log of x is going to be y, and we know that dx is going to be e to the y dy. And so therefore, we're going to get the integral of the sine of y e to the y dy. And now we're going to go ahead and solve that using the integration by parts. So let's go ahead and integrate by parts. So we have the sine of y e to the y dy. And so now we're going to let u equal e to the y, and dv is going to equal the sine of y dy. And so therefore we get du, which is going to equal e to the y dy, and v is going to equal the negative cosine of y, since that's the antiderivative. So let's go ahead and then write our problem again. So we have the sine of y e to the y dy, and that's going to equal u times v minus v du. And so u is ey, and then we have negative cosine for v, so it's going to be negative e to the y times the cosine of y minus negative, so that's v du, so du is e to the y, so it's e to the y times negative cosine of y, so that's cosine of y, and that's dy. So what we substituted is e to the y over here, negative cosine of y, negative e to the y cosine of y dy. Okay, so now we have negative e to the y cosine of y minus, now we're going to integrate this by parts again. So this is going to be plus e to the y cosine of y dy. So we're going to integrate that by parts. So we're going to let capital U equal e to the y. D capital V is going to be the cosine of dy. And then d capital U is going to be ey to the power of ey dy. And then V is going to be the antiderivative of the cosine of y, which is the sine of y. And so then when we want to integrate by parts, it's going to be u times v minus v du. So we have e to the y times the sine of y minus v du, which is going to be e to the y times the sine of y dy. So now we're going to substitute that in for this. So we have negative e to the y times the cosine of y plus e to the y times the sine of y minus the integral of e to the y times the sine of y dy. Okay, so now we're going to bring this down and rewrite it. So this is the same thing as e to the y sine of y dy. And you can see that we have the same term on this side. So this is going to be a plus 1. And so we're going to add this integral to both sides. So we get 2 times e to the y sine of y dy, and that's going to equal negative e to the y times the cosine of y plus e to the y times the sine of y and that's plus 0. And so now let's go ahead and divide by 2. So if we divide both sides by 2, we get 1/2 times negative e to the y cosine of y plus e to the y times the sine of y plus c. And then we can factor out the e to the y. So we get 1/2 e to the y. So we can write the sine of y first, since that's positive, minus the cosine of y, and that's plus c. And so the last thing that we need to do is now replace our y with what we called it at the beginning. And we said that y was equal to the natural log of x. So this is going to be the following result. We have 1/2 e to the natural log of x times the sine of the natural log of x minus the cosine of the natural log of x plus c. And so e to the natural log of x, according to our properties of logarithms, becomes just the variable x. So this is 1/2 x times the sine of the natural log of x minus the cosine of the natural log of x plus c.